we were dealing with in the morning session. We have seen two tools of MATLAB optimization toolbox. One is LeanProg and the other is fmean UNC. Now we will continue with solving constrained nonlinear optimization problems using MATLAB. Solving constrained nonlinear optimization problems using MATLAB. So for this, the function to be used is fmean con, fmin con. We will see. The problem type is like this. Yesterday we have seen this problem. Find the dimensions of a cold drink can with the top and bottom to maximize its volume such that the total surface area is equal to 24 pi. When we formulate this problem, the problem is stated as find RH so as to maximize pi r square h subject to 2 pi RH plus 2 pi r square is equal to 24 pi. So we can see here that the problem is non-linear in nature, first thing, because the objective function is non-linear. Or yesterday only I have told you that if any of the term, if a single term is non-linear, the entire problem is treated as a non-linear optimization problem. For a problem to be linear optimization problem, it is necessary that each and every term must be a linear term. But for a non-linear optimization problem, it is not necessary that each and every term should be is a non-linear term. So any single non-linear term can make the problem non-linear. So here the problem is non-linear, and in this type of case, this is a non-linear multivariable because there are two variables. If you have more than one variable in the problem, it is called multivariable optimization problem. So it is a multivariable constrained nonlinear optimization problem, having only one constraint, and that too it is a equality constraint. For this type of problem, the function to be used is fmean con. F is for function, min for minimization, con for constraint. Constraint function minimization. Constraint function minimization. Fmean con. This finds the minimum, again, see, this finds the minimum of a constrained nonlinear multivariable function. Constrained nonlinear multivariable function, fmean con. So, as we have dealt with other functions also, here also, we have to keep in mind that it considers the objective function to be of minimization type. If the given objective function is of maximization type, it should be converted to minimization type. And we very well know now how to convert the function to minimization type. Simply multiply the objective function by -1. It gets converted into minimization type. All the linear as well as non-linear equalities are considered to be of less than or equal to type. Now, this being a non-linear optimization function for non-linear optimization, and as I said that a non-linear optimization doesn't mean that everything will be non-linear. A non-linear optimization problem can have 4 types of constraint. See, it can have 4 types of constraint. Major category is inequality and equality. Under inequality, the problem can have linear inequality constraint, and the problem can have non-linear inequality constraint. In equality, again 2 categories. The problem can have linear equality constraint, or the problem can have non-linear equality constraint. So linear equality, non-linear equality, linear inequality, and non-linear inequality. This can be the 4 categories, or we can say 4 types of constraints. So all the non-linear inequalities, whether it is of linear nature or non-linear nature, it is considered to be of less than or equal to type. And again, the thing is very true that can we not have greater than equal to type constraint? The answer is yes, we can have. We can have greater than equal to type constraint. The only thing is we shall convert it into less than equal to type by multiplying both sides by -1. Multiply both sides by -1, it gets converted into an inequality of less than or equal to type. So whenever you apply any tool, you have to be very careful. See, why I'm telling this thing again and again, because I have an experience with different STTP, wherein actually I interacted the participants offline. I found that in spite of telling many times, they do not take care of this particular thing, that the objective function should be of minimization type and the inequality should be of less than equal to type. नहीं है तो आपको change कर लेना पड़ेगा. You will have to convert it. Let's see the syntax of fmin_con function in simple form. Why I am saying simple form again? Because there can be a lot of additional things, and as I said, you can go through the MATLAB library, MATLAB literature, and you will get the other things also which can be incorporated additionally. The simplest form is like this: x comma fval is equal to fmin_con, fmincon. This is to be written in small letters only. If you write it in capital letters, that will be treated as a mistake. That will be wrong. It will be treated as a mistake. Fun is a function. Fun is a function. Okay, let's see the things one by one. Left hand side, I need not explain. It is same as we had in case of leanprog and in case of fmin_unc. Same thing, same are the meanings of x and fvl respectively. X is the output vector which contains the values of variables which gives optimum solution. And fval is an output variable containing the optimum value of the function. Optimum means minimum value of the function. Now let's see the meaning of the terms. Those are there on the right hand side. See, meaning of first two terms is exactly the same which we have seen in case of fmin_unc. Fun indicates the function which contains the objective function. It contains the objective function. X0 is the starting point. You have to give the starting point from where to start. Okay, and that is random choice because you do not know the optimum solution. So your random choice may be far away from the optimum solution. Doesn't matter. It will take care and finally it will give you the optimum solution. But sometimes in conventional method, I'll come to that particular point afterwards. I'll take one more tool and then I'll talk about this initial choice again. So Fun and X0, they carry the same meaning as they were having in case of fmin_unc. Let's see the meaning. Fun is the function which is to be minimized. Fun is a function that accepts a vector x and returns a scalar f. The objective function evaluated at x. The function can be specified as a function handle for mfile function. What does this mean? That you have to write the function wherein you will be specifying objective function, and the function name is to be quoted here, wherein it is to be preceded by @ the rate. @ the rate indicates function handler. It is called function handler. The @ the rate and then the name of the function. X0 is the initial choice, is the initial point. The function starts at the point x0 and then it attempts to find a minimum x of the function described. Now, after this, see, Fun and X0, they carry, as I said, they carry the same meaning as given in case of fmin_unc. Now, after this, A, B, AEQ, BEQ, LB, UB. They have the same, exactly the same meaning as we have seen in case of lean prog. What A and B are doing? A and B take care of linear inequalities. A takes care of left hand side of linear inequality. B takes care of right hand side of linear inequality. AEQ, BEQ. What is AEQ, BEQ? They take care of linear equality. AEQ, the left hand side of linear equality. BEQ, the right hand side of linear equalities. LB is lower bound, UB is upper bound. And then you will find one thing additional. Okay, so let's proceed one by one. A is the matrix, each row of which contains the coefficient of variables in the equality constant. B is a vector whose elements are right hand side, that is constants of inequality constants. And of course, A and B are to be written after converting all the linear inequalities into less than equal to type. AEQ is a matrix, each row of which contains the coefficient of variables in the equality constants. And BEQ is a vector whose elements are right hand side of equality constant. Then LB is a vector that contains the lower bounds of the variables, and UB is a vector which contains the upper bound of the variables. So lower bound and upper bound of the variables. Now talking about the last term, that is non-LCON. Non indicates non, L indicates linear, non-linear, and CON means constraints. See, we have taken care of everything apart from non-linear constraints. So we have to specify non-linear constraints, and non-linear constraints can be of two categories: non-linear inequalities and non-linear equalities. So they are all specified in a separate function, and that function shall appear with the function handler, again @ and function name. So non-LCON is the function that computes the non-linear inequality constraints and the non-linear equality constraints. Inequality as well as equality. Actually, this function f mean con is little bit, I feel that it is probably little bit difficult to understand in online mode. When you will practice this, you will realize that yes, what is exactly to be done. So this needs a lot of practice, f mean con, and this is, I will say, most widely used tool, because mostly, as in the morning session, after the session we had a discussion with another faculty resource person. Probably he is having session on next Monday. So as we were having discussion, you must have realized that most of the problems are constraint problems and most of the problems are non-linear problems. So what we can say, that most of the problems are non-linear constraint optimization problems. So far as electrical engineering is concerned, in electrical engineering also, most of the problems are non-linear constraint optimization problems. And hence, this is the most widely used function of MATLAB toolbox, f mean con. Okay, sometimes, see, one more thing I would like to emphasize here is, sometimes what happens, a particular researcher, I have seen some researchers, what they do, they solve the problem using sequential quadratic programming method. Okay? Problem is solved using sequential quadratic programming method, and they have got the solution. Then they apply sequential quadratic programming method manually. After understanding the method, they apply the method and they get the solution. And then they solve the same problem using f mean con, and they get the result. They compare the result and then say that the results are exactly same. Something like that. This is the conclusion, and then from the conclusion they derive something, and that. Mind well, that when there is a function in MATLAB toolbox, that function must have been written using some of the method. ऐसा फंक्शन कोई ऐसा चमत्कार जादू, द फंक्शन इज नॉट ए मैजिक. फंक्शन इज नॉट ए मैजिक. फंक्शन कोई जादू तो नहीं है कि फंक्शन लिख दिया एंड यू हैव गॉट द सॉल्यूशन. नो, इट इज नॉट ए मैजिक. It is a function means it is basically a program which is written and made available, already written and made available. When I say that it is a program already written and made available for use, definitely that must be a program which is written using some method. So if you go into the details, you will find that fmean_con function has been written basically by using sequential quadratic programming method. Sequential quadratic programming method. And that is why I say there is no meaning in comparing the results. The results are bound to be correct, bound to be same. Fmean_con, the result obtained using fmean_con function in MATLAB and the result obtained by manually solving applying sequential quadratic programming method. Because what is fmean_con? That is actually a program of sequential quadratic programming method. No need. So this type of comparison is, I say, I'm sorry to say, but this type of comparison is a useless comparison. The function itself is using SQP method and you are also using SQP method, comparing and saying that I'm getting the same result. There is no meaning. Anyway, come back to our topic. Non-LCON. Non-LCON is the function that computes the non-linear inequality. So, non-linear inequalities are to be written in a separate file. So now see that when I am using fmean_con, I will have to write 3 different files, 3M files. Which 3M files? First file will contain main program. I will show you a small example of design of a cylinder. I will take that problem and will show you 3 different files. So I'll have to write 3 different files. First file will contain the main program. Second file will contain FUN. FUN means what? The objective function. Remember that if you are using fmean_con function, even if the objective function is linear, it is very much possible that the problem is non-linear because of non-linearity in some of the constraint. The objective function is linear. But as there is some non-linearity in some of the constraint, the problem is non-linear problem. So, if you are using fmean_con function, that is, you are trying to solve a non-linear constraint optimization problem. Even if, remember, even if your function is linear, it has to be written in a separate file. You cannot write it in the main program just by writing the coefficient of the design variables, as we did in case of linear programming. Because in linprog it is fixed that you are going to solve linear problem only. Here it is fixed that you are going to solve a non-linear problem. Even if the function is linear, it has to be written in a separate M file. So first file containing main program, second file containing a function subprogram wherein you are defining the objective function. There will be one more M file, and that M file will contain non-linear constraints. So 3 M files. I'll just revise. If I am using linprog function, I need to write only one file, that is main file. If my problem is unconstrained nonlinear problem, I will be using fmean_unc. I will be writing 2 files, one main file and other function file. Now, if I am trying to solve a nonlinear constraint optimization problem, I am using fmean_con. I will have to write 3 different files, main file, file for objective function, and a file for nonlinear constraints, which will include nonlinear inequality as well as nonlinear equality. One more thing, when I explained linprog, I have explained that you can do everything without writing any program. You can do it with the help of GUI. Okay, using the command. So fmin con and fmin unc also can be handled in that way, but remember, only the main file can be replaced by that GUI. And in that GUI, it will ask for another file which contains objective function. So that you will have to, वो तो आपको लिखना ही पड़ेगा. Likewise, when you are going to use fmin con, at that time, even if you are using GUI, you will have to write two files. One will contain the objective function, and the other will contain the non-linear constraints. The other will take the non-linear constraints. So ये दो फाइल तो आपको लिखना ही पड़ेगा. You cannot escape from this. And if you are not using GUI, you will be writing three files. In addition to these two, you will be writing main file. The function non-lcon accepts a vector x and returns two vectors c and ceq. C takes care of non-linear inequalities and ceq takes care of non-linear equalities. C contains the non-linear equalities evaluated at x, and ceq contains the non-linear equalities evaluated at x. The function non-lcon can be specified as a function handle. Expert lectures with STD. So now we'll see a problem and how it can be handled using fmin con. Find the dimensions of a cold drink can with top and bottom to maximize its volume such that the total surface area is equal to 24 pi. This is the problem which can be formulated in this way. We have already seen yesterday. Okay. Now we will see how to solve this problem using fmin con. There are few things which we should keep in mind before proceeding for solution. Two things I have already told, that the objective function should be of minimization type. Second, if you have any inequality constraint, whatever it is, whether it is linear or non-linear, it should be converted to less than or equal to type. In addition to that, one more thing is to be taken care of while using fmin con, and that is all non-linear constraints should have right hand side is equal to 0. So if you have a non-linear inequality, first convert it into less than equal to type. After that, whatever you are having on right hand side, transfer it to left hand side so that right hand side will be 0. And for equality constraint, there is no problem. If you have anything on right hand side, transfer it to left hand side so that right hand side is equal to 0. So this is an additional thing that we have to do. What we have to do is all the non-linear constraints, before applying fmin con, all the non-linear constraints should have right hand side is equal to 0. This is the problem. See what I am doing. Find RH. I am rewriting the problem. See the difference in the objective function. So as to minimize f. It was maximize v. Now I am saying minimize f is equal to minus pi r square h. And see what I did. Because the constraint is non-linear constraint, just see what I did. It is a equality constraint. I transferred the quantity on right hand side into left hand side, and I have written the constraint as 2 pi rh plus 2 pi r square minus 24 pi is equal to 0. So this is the preliminary thing before applying fmin con. Of course, RH greater than equal to 0. And as I said that I will not treat this as a constraint and convert it into less than equal to type. No, this is a lower bound. This is a bound. No need to convert it to less than or equal to type. See, the first function, the main file, first file, the main file, it contains what? And you have to write 3 files, but keep in mind that the files are very small. You just have to write few lines. Say, for example, first file, which is a main file. The name which I have given to this file is demo_fmeancon.m. There is one thing more. Those who have used MATLAB, they know this thing, but those who are beginners, what they do, they write a program and name it as fmeancon because they are using fmeancon. So, याद रखने के लिए अच्छा होता है. The moment you name the file as fmeancon, your file gets higher priority as compared to fmeancon function defined by the MATLAB. You cannot use that function. आप fmeancon बोलोगे तो आपकी फाइल रिकॉल हो जाएगी उधर. So be careful. Do not use the functions which are already there. Do not use those function names to specify the file name. कुछ तो भी अलग नाम देना पड़ेगा. So I have given the name as demo_fmeancon. CLC clear all, the meaning is known to you. X0, the initial choice given as 0, 0. Lower bound for R and H, we know that R and H, radius and height of the cylinder, has to be greater than equal to 0. It cannot be negative. So lower bound is 0, 0. Upper bound is not given, so not specified. And then I am saying fmeancon. See, purposefully I have written a comment which is shown in green color just to show that what is appearing in place of what. It is for better understanding. Just आपको बताने के लिए, समझाने के लिए मैंने उसका syntax लिखा है. I have written the syntax in green color. fmeancon, fun is the function which will contain the objective function, and it has to appear with function handler, that is at the rate. So see, in place of fun I have said @share. Share is the name of function which I have decided that I will be writing a file named share.m, and in that file I'll write the objective function. Then x0 I have defined here. You can see x0 0, 0, the initial value. Then a, b, aeq, beq, they take care of, ab take care of linear inequality. aeq, beq take care of linear equality constraint. You can just see the problem and you will realize that in our problem we do not have any linear constraint. Neither we have linear equality constraint, nor we have any linear inequality constraint. So in place of that, bracket open close for AB, similarly for AEQ, BEQ. Why? Because we have to define further things. And as we have to define further things, earlier things cannot be skipped. आप छोड़ नहीं सकते. Syntax, as per the syntax, you have to specify them, but they are not there. So simply say bracket open close, and so on. Then lower bound we have specified here 0, 0. You can see lower bound is specified 0, 0. So LB. Now, if you recall, in case of linear programming problem, when upper bound was not given, we terminated our parenthesis here only after LB parenthesis close. But now this is a use of fmeancon. Fmeancon must have a function which will contain non-linear constraints. If your problem is having non-linear constraint, then this non-lcon will be there. And if at all you want to use this, whatever is before that must be specified. उसके पहले का सब specify करना ही पड़ेगा आपको. Upper bound is not there, you will say bracket open close. One more thing, that if your problem do not contain any nonlinear constraint, if your problem doesn't contain any nonlinear constraint, then you can avoid writing that file non-LCON. In that case, if upper bound is also not there, then you can close the parenthesis after lower bound. But we can see that our problem is containing a nonlinear constraint. So last is non-LCON, means a file which will contain nonlinear constraints. I have decided that the file name will be Bhalu. The file name which will contain objective function is share, and the file name which will contain the nonlinear constraint is Bhalu. So @Bhalu. Okay, that's all. This is what you have to do in main program. So just 3-4 lines, not more than that. Just 3-4 lines. Initial 3 lines you can forget about. Demo function, that is comment CLC clear all. Then 6th line also you can forget about. So what is important is line number 4, 5 and 7. That's all. So basically it is a 3-line program. Basically it is a 3-line program. Now we will see what should be there in the function share and what that Bhalu should contain. Share में क्या होना चाहिए और Bhalu में क्या होना चाहिए? This is what we will see now. Second file, which is a function share. The function name must be share and the file name must be share.m. Once you have decided the name. What this should contain? This should contain the objective function in minimization form. It is pi r square h. So the contents will be available in P. The first variable value will be taken as P1, second variable value will be taken as P2. So I am storing P1 in R and P2 in H. And then saying that function is equal to minus pi r square h. Why minus? Because pi r square h is to be maximized. So minus pi r square h is to be minimized. And instead of writing these 2 lines, line number 2 and line number 3, I could have avoided this and I could have directly written that f is equal to minus pi multiplied by P1 multiplied by P1 multiplied by P2. That I could have done easily, no problem. But for better understanding, I have transferred the quantities into R and H. This is second file, which contains the objective function. Now talking about the third file, that is this Bhalu. So we have seen share, now we will see Bhalu, which contains the non-linear constraints. Here again, the value of variable, a design vector, current design vector will be taken from P. So first vector is, first variable is R, second is H. So I have said R is equal to P1, H is equal to P2. C indicates C1, C2, C3, etc. They indicate or they are used to define the nonlinear inequalities. Nonlinear inequalities. And CEQ1, CEQ2, etc. they are used to define nonlinear equalities. This particular problem do not have any nonlinear inequality. So C is equal to bracket open close. And this particular problem is having only one nonlinear equality. So we have only CEQ1, which is 2 pi RH plus 2 pi R square minus 24 pi. So nonlinear equality after transferring everything to left hand side, right hand side is equal to 0. So I have to write a function for objective function. I have to write a function for nonlinear constraints, equality as well as inequality. And after this, I will go back to first file, that is demo_fmaincon, which is main file. And then I will run the program. After running the program, I will get the result. The result is x is equal to 2 and 4. which indicates that radius is equal to 2 and height is equal to 4. Function value is minus 50.2655. So actually the function value is positive 50 because our original function was of maximization type. So actual function value is positive 50.2655. So this is how we have to use f mean con. This particular function needs lot of practice. When you use, actually you need lot of practice. There are different things that come and we have to handle all the situation. So for that practice is required. Anyway, I'll continue with one thing which will give you an idea what is to be written where. Constraints, as I said, that the constraint can be of 4 different types in this particular case. Linear inequality, linear equality, non-linear inequality, non-linear equality. You can just read this and you will realize what is to be written where. Linear inequality, they are to be written in main file. Linear equality also to be written in main file. So linear constraints are to be written in main file. Inequality, left hand side to be taken care of by A, right hand side to be taken care of by vector B. Equality, left hand side to be taken care of by matrix AEQ, right hand side vector BEQ. This is regarding linear equality and inequality. Linear constraints, in case of linear constraints, you need not transfer everything to left hand side and all that. जो लिखा है जैसा है वैसे ही रहने दीजिए. But in case of non-linear, you have to transfer entire thing on left hand side. Non-linear inequality, non-linear equality, they are to be written in a separate function. As we did in this particular case, we had a separate function named as bhalu, and there we wrote the non-linear constraints. Now I will take one more tool and then I will take applications to electrical engineering. I'll try to cover, say, 2 or 3 or 4 applications to electrical engineering. Global optimization technique, genetic algorithm. I think that somebody will be talking on genetic algorithm afterwards in the coming days, coming sessions. I am not going into the details of genetic algorithm. I am not going to take a session on genetic algorithm. I will just tell you that if you are using MATLAB optimization toolbox, how can you solve your problem using genetic algorithm instead of f-mean con, which uses sequential quadratic programming, which is a conventional method. In case of conventional methods, we have seen that we have to specify this x0, the initial choice. What happens that if the initial choice is nearer to local optimum solution, if the initial choice given, because you do not know the solution, you are trying to find out the solution, but you have to start with some random solution to be given. It is exactly similar to what we do in case of Gauss-Seidel method. We solve the simultaneous linear equations. Let's say we have 3 equations with 3 unknowns x1, x2, x3. What do? We write an equation for x1 using first equation. We write an equation for x2 using second equation, and then third using x3 using third equation. And we have to give some starting point. Then only we can proceed. Similarly, in case of conventional optimization methods which are used for non-linear problems, we have to specify the initial point. And unfortunately, if the initial point specified by you, given by you, falls or is near the local optimum solution, then the conventional method will take you to the local optimum solution. It will stuck up there and will declare that no further search direction is found out and this is the optimum solution. Whereas actually the optimum solution may be different. What I mean to say is conventional optimization technique do not give any guarantee that you will get the global optimum solution. Whereas there are many nature inspired algorithms nowadays which give you global optimum solution. Genetic algorithm is one of them. Genetic algorithm, particle swarm optimization, which I named yesterday, gravitational search algorithm, owl algorithm, Firefox algorithm, bacterial foraging algorithm, anything you pick up, ant colony optimization, they all will give you global optimum solution. So genetic algorithm is one of the techniques which is inspired from natural genetics, and it is a technique which leads us to global optimum solution. So let's see the tool. As I said, I am not going into the details of genetic algorithm, how it works and all that. I'll be taking the tool which can be used for solving our constrained nonlinear problem using genetic algorithm. The tool is, or the function is GA, small g, small a. जैसा उधर lean prog, f mean UNC, f mean con, likewise GA. GA. This implements the genetic algorithm to minimize an objective function. That thing is here also it is applicable. It minimizes the objective function. It minimizes the objective function. If the fitness function, in case of genetic algorithm, the objective function is called fitness function. The meaning is same. It is objective function only, but in genetic algorithm, because it uses the concept of natural genetics, the objective function is called fitness function. So if the fitness function, that is objective function, is of maximization type, you have to convert it to minimization type, as usual. Then, all the linear as well as non-linear inequalities are considered to be of less than or equal to type. Very much similar, very much parallel to f mean con. These things are same. You will find that the syntax is also similar with a very, very small difference. With a very small difference. Let's see. The syntax of GA function in simple form. Syntax of GA function in simple form is like this. X comma FVAL. X comma FVAL is equal to GA fitness function NVARS AB AEQ BEQ LB UB non L con. These are the things. So you will find that afterwards I have a slide. I think I don't remember exactly. Probably I have a slide wherein I'll show you the comparison, and then you will realize that there is a very small difference between using the GA function and using f mean con function. Left hand side, things they carry the same meaning. Output vector which contains the values of variables which gives optimum solution. FVL is an output variable containing the output value of the function. Then in place of f mean con, it is GA. Then fitness function. Meaning of fitness FUN is same as we had in case FUN. Is the function to be minimized? Same thing. Only thing is representation uska alag ho gaya hai. In place of FUN, I am writing fitness FUN. It has to be written in a separate file. It has to be written in a separate file, and it is called with the help of function handler at the rate. At the rate se call hota hai. Then there is a difference NVAR. In place of X0, we have NVAR. What was X0 there? The initial choice. And What is the drawback of conventional optimization technique? One of the drawbacks, there are many, but one of the drawback is that you have to give an initial point. And if your initial point is lying nearer to, if it is lying nearer to local optimum solution, then the method will lead to the local optimum solution and you will not reach to global solution. Here in case of genetic algorithm, there is no question of x0. We are not specifying x0. We are not giving any initial choice. And hence, finally, it leads to global optimum solution. What is NVAR? NVAR is number of variables. Simply, you have to write how many variables are there in your problem. Number of variables. And remaining all things, they carry the same meaning as we had in case of F mean con. A, B, AEQ, BEQ. They are written in main program. They take care of linear inequalities and linear equalities. Linear inequality constraints taken care of by AB, left hand side, right hand side. Linear equality constraint taken care of by AEQ, BEQ, left side and right side. LB is lower bound and UB is upper bound. You will find that purposefully I have underlined some of the words. Linear inequality, linear inequality, linear equality, linear equality. What about non-linear constraints? They will be written in a separate file which will be called as non-LCON, as we did there. So you will find that there is only one difference. Let's see the comparison. Yes, the slide is there. I was not sure whether the slide is there or not. F mean con versus GA. The syntax of the F mean con function in simple form is this, and the syntax of is this. If you just compare, you will find that there is only one difference. And what is that difference? Difference is that x0 you have in case of F mean con, and you have number of variables in case of genetic algorithm. That is the only difference. I am marking the difference by red color. This is the only difference. All other things are same. All other things are same. This GA also you can solve using GUI. GA tool बोल दिया तो GUI का genetic algorithm activate हो जाता है. But then you will have to be ready with a file containing objective function, and you will have to be ready with a file containing the non-linear constraints. That you will have to prepare and write before using GA function, either GA function or GA2. Okay, now with these four tools, as I said that there are many tools, and taking each and every tool in detail with variety of examples, it can be a separate STTP. So we will now proceed to few of the applications, because while explaining the tools, I have taken general problems. Now I'll be taking, depending upon the time, I'll be taking 2 or 3 or 4 applications. Overcurrent relay coordination, application in electrical power system. Overcurrent relay coordination 1. 1 means this is the part 1 wherein we consider that only time multiplier setting is variable and the plug settings are fixed. Plug settings are fixed. So if that is the situation, how the problem looks and how it can be solved. Just a background, small background of overcurrent relay coordination, and then we will proceed for the problem formulation. The most obvious effect of shunt fault is a sudden buildup of current. Now probably all of you must be feeling that yes, we are dealing with electrical engineering. Till now, there were no terms like resistance, inductance, capacitance, current, fault, and voltage, and nothing like that. So now we are coming to our domain area. But you will realize that whatever I said is very true yesterday. Whatever I said yesterday is very true. If you know the tools properly, and what I said yesterday, most important is if you can formulate your problem properly and correctly, you can get the solution very easily. I have explained how to formulate the problem. I have explained how to use the tool. Now we will combine these two things and we will see 2 or 3 electrical engineering applications. The most obvious effect of shunt fault is a sudden buildup of current. And that is why it is very natural. One should think that magnitude of current should be utilized as a positive indication of fault. If magnitude exceeds a particular limit, which is already calculated, pre-calculated, how it can be pre-calculated? You know the load plus 25% safety margin. If the current exceeds full load current plus 25% of that, or 20%, whatever safety margin you have kept, then it is treated as a fault current. So magnitude of current can be very easily utilized as a positive indication of fault. Therefore, the most commonly used and most widely used protection is overcurrent protection. And this is the protection which is taught as the first protection scheme whenever we teach power system protection. Overcurrent protection, simplest type of protection and most widely used type of protection. Almost in distribution system, almost everywhere overcurrent protection is used. Even for some cases, in case of say transmission network, overcurrent protection is used. Sometimes in case of transmission network, we use distance protection as primary and overcurrent protection as backup. That is, of course, the special case. Now, a relay must get sufficient chance to protect the zone under its primary protection. Only if the primary protection does not clear the fault, the backup protection should take over tripping. Just to understand what is mentioned in this sentence, let's see this particular diagram. A simple radial system. For understanding purpose, I am taking a simple radial system consisting of 2 sections and hence 2 relays, relay RA and relay RB. There is a fault in the second section, section B to C. Between feeder B to C, there is a fault. Now, as there is a fault, the fault current will start from the source. And it is flowing through relay RA, through relay RB. What does this mean? As the fault current is going through RA and through RB, of course, when I am saying flowing through relay means it is stepped down. Secondary side of relay contains very small amount of current, stepped down value of current. So, as the current is flowing through, going through RA, RB both, even though the fault is in the section BC, it is sensed, identified by both relay RA as well as relay RB. Both relays come to know that yes, there is a fault. But a relay must get sufficient chance to protect the zone under its primary protection. At present, the fault is in the primary zone of relay RB. So relay RB should be given sufficient chance to clear the fault. If RB fails to clear the fault, then only RA, which is backup at present, then only relay RA should operate. Okay? Then only relay RA should operate, otherwise not. That is actually coordination. Both have sensed the fault. But let's give it, why it should be like that? Because if relay RA operates and opens the circuit breaker, associated circuit breaker, the entire system, I mean A to B section will also be in dark and B to C will also be in dark. Major portion will feel the or will have power failure. That should not happen. To avoid that, the chance should be given to relay RB, sorry, which is primary. I'll just for better understanding, I'll compare it with a thing. Let's say that something wrong is going on. Something wrong is going on in electrical engineering department. The students are on strike or something like that. Of course, it should not happen, but just consider that the students of electrical engineering uh, are doing some mischief, maybe strike or something like that. Head of the department comes to know that the students are doing something wrong, HOD electrical. At the same time, principal or director of the institute also comes to know that there is something wrong going in the electrical engineering department. Principal should not, in my opinion, my philosophy is exactly similar to this primary and backup protection. Principal should not act immediately. Principal should wait and watch for some time. Principal should give sufficient time to head of the department to rectify the fault. Whatever wrong is going on, let the head of the department tackle the problem and rectify the problem, solve the problem. If HOD is not able to solve the problem, then only the problem should be taken over by principal. That philosophy is actually primary backup protection philosophy. So, only if the primary protection does not clear the fault, the backup protection should take over tripping. That is, but the fault is sensed by both. Fault is sensed by both. So just wait and watch for some time by relay RA. That is done with the help of proper coordination between relay RA and RB, and that is why the name is given as relay coordination. The coordination problem of overcurrent relay can be stated as an optimization problem, wherein what should be the objective? The sum of the operating times of relays of a system is to be minimized. Why the operating time of relays is to be minimized? Less is the time of operation of relay, less will be the time of operation of circuit breaker. That is, the fault will be cleared with higher speed and there will be less loss. So to avoid losses, to avoid power failure, there should be proper coordination. Time of operation of relay should be as minimum as possible. So it can be stated, the objective function can be stated as minimize Z. What is to be minimized? The sum of Wi, Tik. Wi is actually the weight given, which depends upon the length of distribution feeders. And most of the times we consider that the distribution system is small system. So we consider that each part, each section or each feeder is having same length approximately, and hence we take weight is equal to 1. Wi is equal to 1. Otherwise you will have to provide some weight. Tik indicates time of operation of relay located at I, time of operation of relay located at I for fault that has taken place at point K. That is Tik. The total time of operation of relays of a system is to be minimized. Now this is objective function, and it is not a problem where we do not have a limitation or restriction. There are limitations, restrictions, and those are the constraints. Let's see the constraints. This objective is to be achieved under 3 sets of constraints. As at present, I am considering that time multiplier setting of overcurrent relay is the only setting that is the only variable, I have to find only the optimum value of time multiplier setting so as to minimize the total operating time of relays of a system. Then there are three constraint sets. If I consider that I want to find optimum value of time multiplier setting as well as optimum value of plug setting, both, then there will be 5 set of constraints and the problem will be non-linear. Afterwards, I will take that also. वो भी problem लेंगे बाद में, wherein the problem will be a non-linear problem. What are the 3 sets of constraints? Let's see. Constraint set number 1 is called coordination criteria. Tik minus Tjk should be greater than or equal to delta T. What is Tik and what is Tjk? Tik is the time of operation of relay I per fault at point K, and Tjk is time of operation of relay J per fault at point K. So for the same fault at point K, I am talking about time of operation of relay located at I and J. So I am considering that relay located at J is primary relay and relay located at I is backup relay. So for the fault occurring at point A, ith relay is backup and jth relay is primary. And backup relay has to wait and watch for some time. For how much time? That time should be greater than or equal to delta T. This delta T is called coordination time interval. Sometimes or some books name it as STI, selective time interval. Coordination time interval, CTI. So delta T is CTI. So the first constraint set is coordination criteria. Why I am saying constraint set? Because depending upon the system size, depending upon the number of relays, there will be number of coordination criteria. Number of coordination criteria. In case of radial system containing 2 relays only, there will be only one coordination criteria. But as the system size goes on increasing, there will be n number of coordination criteria. So this is one. Second set of constraint is bounds on the relay operating time. Tik, time of operation of relay located at I for fault taking place at point K is Tik. That has to be greater than or equal to Ti minimum and should be less than or equal to Ti maximum. Why greater than or equal to Ti minimum? Because every relay have got some limitation. Even if we say that the relay is an instantaneous relay, it actually doesn't operate instantaneously. An instantaneous relay doesn't operate instantaneously. It takes some time. Only thing is that the time is fixed. The time is fixed. But instantaneous relay, name given is instantaneous relay, doesn't mean that it operates in 0 time. No, it doesn't operate in 0 time. So every relay have got a limitation. It has some small operating time minimum. And one should not allow the time to exceed beyond a particular range. So Ti max. Then there is bound on time multiplier setting of the relay. Bounds on time multiplier setting of the relay. Time multiplier setting of any relay has to be in the range minimum to maximum. You can get the range of TMS in literature. I have mentioned the range of this. Of course, I referred from some literature and I have mentioned in some of my papers. So why I have not given a separate number to this particular constraint set? You will find that I have written this under the second set of constraint only. अलग से इसको, this is not numbered as third. This is not numbered as third. It is because so long as we consider that plug settings are fixed, Okay. If we are taking that the plug settings are fixed and constant, then either TMS constant or TIK constant, matlab time of relay operating time constant. Any of these two serves the purpose, other becomes the redundant constraint. What is a redundant constraint? A constraint in optimization is said to be redundant if it doesn't affect the feasible solution or optimum solution. Just to explain, I can say that if I am having two constraints, the first constraint says that x should be greater than or equal to 4. First constraint says that x should be greater than or equal to 4. And the second constraint says that x should be greater than or equal to 6. Okay? If I want to satisfy all the constraints, I will have to choose the value of x which will be greater than or equal to 6. So the first constraint, x should be greater than or equal to 4. Whether that constraint is there or not there, it is not having any effect. So that is becoming redundant constraint in this case. X greater than equal to 4, and the next constraint or the some other constraint is x greater than equal to 6. In this case, x greater than or equal to 4 is called a redundant constraint. Okay? So here also, if we are considering that the time multiplier settings are fixed, then the operating time can be written in terms of time multiplier setting directly, and either the operating time constraint or the time multiplier setting constraint that become redundant. That is why it is not written separately. Then the third set of constraint is the relay characteristic. We are talking about overcurrent relays only at present. Overcurrent relays, operating time of overcurrent relay is lambda into time multiplier setting upon plug setting multiplier raised to power gamma minus 1, where lambda and gamma, they depend upon different type of overcurrent relays. Let's have a look on that particular chart. If I'll show you the chart afterwards. If the pickup currents of relays are predetermined, then the objective function becomes minimize Z is equal to AI into TMS. You can just see here. Okay, this is time of operation of relay. Lambda into time multiplier setting upon plug setting multiplier raised to power gamma minus 1. Plug setting multiplier can be written as the ratio of secondary current. Which secondary current? Relay का secondary current divided by the plug setting. This ratio is called plug setting multiplier. So if plug setting multiplier is fixed, for a particular fault, the current will be constant. For a particular type of relay, lambda and gamma is also constant. So we can take A is equal to lambda upon plug setting multiplier raised to power gamma minus 1. It will be constant. So long as plug setting is considered to be constant, this remains constant. So what we get is A multiplied by time multiplier setting is equal to the time of operation of relay. These are the values of lambda and gamma. Instantaneous relay, operating time is fixed. See, what is instantaneous relay? No intentional time delay is added. Doesn't mean that it operates actually instantaneously in 0 time. No. It has got a fixed operating time. Only thing is that we are not providing any intentional time delay to that. Definite time relay is similar to instantaneous relay, but then the difference is that we have some predetermined fixed time. Intentional time delay is added. Then we have 3 different characteristics, wherein The operating time depends upon the value of current. Inverse definite minimum time, IDMT, most commonly used overcurrent relay is IDMT relay, inverse definite minimum time. And for this type of relay, lambda and gamma are 0.14 and 0.02 respectively. Very inverse relay 13.5 and 1 respectively. Extremely inverse relay 80 and 2 respectively. So these are the values of lambda and gamma for different type of relays, different type of overcurrent relays. Now let's take a simple problem, because a big problem cannot be taken here, cannot be explained here. So I am taking a simple problem which will give you a concept, and same concept can be applied to big problems also. You can refer different papers or different literature, books, wherein you will find big problems available. Consider a simple radial system, and the data, I have assumed some data. The maximum fault current just beyond bus A and bus B are 4000 and 3000 respectively. That is, if the fault takes place beyond bus A but before bus B, the fault current is 4000 amperes. If fault takes place between B and C, the fault current is assumed to be 3000 amperes. Of course, between B and C also, depending upon the location, the fault current will be different. We generally take in relay coordination problem, we take the midpoint of the feeder and find the minimum fault and maximum fault at that particular point. The plug setting of both the relays are 1. Plug setting is 1 means, in some other words, it can be said that plug setting is 100%. 100% means 1. See, now, as I am taking a particular problem related to overcurrent relay coordination, those who are not in the touch of power system protection at present, they may not recall this, but so anyway, we will continue. The plug setting of both the relays are 1 means 100%. The CT ratio for relay RA is 300:1, and that for relay RB is 100:1. These are the CT ratio which are associated with the relays, 300:1 and 100:1. Minimum operating time for each relay is to be considered as 0.2 second, and CTI, the coordination time interval, is to be taken as 0.57 second. We will formulate this problem. We will see what is the nature of the problem, and accordingly we will see what is the function that can be applied to solve this problem. This is purely electrical engineering problem related to core electrical engineering power system protection. Now we will relate optimization with electrical power system. So yes, here is the application. Let's formulate the problem and see what we get. Here we have calculated the AI constant. AI मतलब क्या है? AI मतलब क्या है? Lambda upon plug setting multiplier raised to power gamma minus 1. So if a fault takes place just beyond point A, somewhere here, somewhere here. The value of AI constant for relay RA will be 2.63. It is 0.14 into 13.33 raised to power 0.02 minus 1, which comes out to be 2.63. There is no question of RB here, relay B, because the fault is somewhere here. Relay B cannot sense the fault, cannot look at the fault. Okay, it cannot look at the fault because relay B is looking in this direction, directional relay, B to C. If there is any fault in the range B to C, this relay will take care of. But fault on the left hand side, relay B cannot see, that is why dash. Fault just beyond B, fault will be seen by both relay RA and RB. And the calculation of AI constant for RA comes out to be 2.97. For RB, it comes out to be 2. Let's see how these values are calculated in brief. Let's see in brief. Time of operation is given by lambda into time multiplier setting upon plug setting multiplier raised to power gamma minus 1. we are defining A as lambda upon plug setting multiplier raised to power gamma minus 1. I am assuming that at present in this particular system, IDMT relays are used. For IDMT relays, lambda is 0.14 and gamma is 0.02. We have seen this in the previous chart that lambda is 0.14 and gamma is 0.02. So, considering these relays to be IDMT relays, lambda is 0.14, gamma is 0.02. Now let's see the other calculations. This is lambda upon what is plug setting multiplier? Relay secondary current divided by plug setting multiplier, that is divided by plug setting, which is 1 given in the problem. Now let's see the calculation. Let's see the statements given in the problem. For we are doing calculation, we are talking about this. We are talking about this. How we have got 2.63. So for fault just beyond bus A, fault current is given in the problem. We have calculated, rather you can say we have calculated using the impedances of the feeders. We have calculated that the fault current is 4000 amperes. CT ratio for relay RA is given as 300:1 and plug setting of relay RA is given in the problem as 1. With this, let's see the calculations. As it is IDMT relay, lambda is 0.14 divided by IS. What is IS? The current seen by the relay. Current seen by the relay means CT secondary current. CT secondary current. CT primary is carrying a current of 4000 amperes, the fault current. So it is 4000 divided by the CT ratio. CT ratio is 300:1. So 300 amperes in primary will result into 1 ampere in secondary. Likewise, 4000 ampere in primary will result into 4000 upon 300 amperes in secondary. So this is secondary current. Then plug setting of relay RA is 1. So plug setting is equal to 1. This plug setting is equal to 1. Okay. Raised to power 0.02 because it is IDMT relay. So gamma is 0.02 minus 1. This is how we calculate AI constant, this first one. And we have got 2.63. In the similar way, now we will consider fault just beyond bus B, that is this. We will now see fault just beyond bus B. For fault just beyond bus B, fault current is 3000 amperes. CT ratio for relay RA is 300:1. Relay RB, it is 100:1. Plug setting of relay RA is 1. Plug setting of relay RB is also 1. Let's see the calculation. Fault current is 3000 ampere. Relay considered is IDMT relay. As the relay is IDMT relay, we have lambda is equal to 0.14 divided by secondary current of relay. Relay secondary, CT secondary current. Current seen by the relay. Fault current is 3000 and I am talking about relay A. As I am talking about relay A, I will take CT ratio 300:1. That is why here it is 3000 upon 300 divided by, as the plug setting is 1, so divided by 1. Raised to power 0.02, IDMT relay, value of gamma is 0.02 minus 1. This calculation gives us 0.14 upon 10 raised to power 0.02 minus 1. So this gives us the value 2.97. Now for the fault just beyond B, we will do this calculation AI constant for relay B. IDMT relay, so 0.14 divided by, the fault current is same. Whatever is the fault current seen by relay A, same is the fault current seen by relay B, because I am considering this as radial system. There is no any other path which can take the current and which can make the two currents unequal. There is no other path. So whatever current is flowing through RA, same is flowing through RB. That is 3000. But relay RB, the CT ratio is 100:1. That is why here it is 100. Here it is 100. Divided by 1. Flux setting of relay RB is also 1, so 1. Raised to power 0.02. IDMT relay gamma is 0.02 minus 1. This gives us 0.14 divided by 30 raised to power 0.02 minus 1, which gives us value 2. So this is how we have calculated AI constants. Now, after calculating AI constants, we will proceed for formulation of the problem. This is what we have got in previous slide. For two fault points, fault just beyond bus A, AI constant for relay A is 2.63. Fault beyond bus A but before bus B is not seen by relay RB, so dash. Fault just beyond bus B, AI constant for relay RA is 2.97 and that for RB is 2. Now let's proceed for the formulation. What we have to do, our aim was to find out time multiplier setting of relay RA and RB so as to minimize the total time required for operation of relays in the system. Considering X1 and X2 as time multiplier setting of relay RA and RB, respectively, the problem can be stated as minimize 0.56 X1 plus 2 X2. From where I have got this 5.6. 5.6 is the AI constant addition for relay A. 2.63 plus 2.97. This results into 5.60. 5.60. So 5.60 into X1, A1 into time multiplier setting 1 plus A2 into time multiplier setting 2. A2 is 2 because relay B can see only the fault beyond B. तो उसके लिए पहला dash है. Dash means 0. 2 plus 0 is 2. So 2 into X2. This is to be minimized. So I can say that there are two design variables. One is time multiplier setting of relay A and the other is time multiplier setting of relay B. And the objective function with the help of these two design variables can be written as 5.6 X1 plus 2 X2. This is the objective function. Now let's talk about the constraints. The first constraint is the coordination constraint, coordination criteria. Because we have only two relays, we are taking very simple case. We are having only one possible pair of primary and backup. Primary backup का एक ही pair है, RA, RB, that's all. So for any fault in the section B to C, for a fault in the section B to C, RB acts as primary relay and RA acts as backup relay. Time of operation of relay RB, per fault in the section BC is given by 2x2 and time of operation of relay RA for fault in BC is 2.97 times x1. So the difference between 2.97 x1 minus 2 x2 has to be greater than or equal to the coordination time interval, which is given as 0.57 in the problem. Generally, coordination time interval is not so large. 0.57 is so large. Practical value itni nahi hoti hai. Let me make it clear. Practical value is smaller than 0.57. But I have taken some random values. I wanted to show how problem can be formulated, how it can be solved. That's all. So 0.57. Now, relay operating time constraint. 2.63 x1 should be greater than or equal to 0.2. What is 2.63x1? 2.63x1 is the time of operation of relay RA for fault in the section A to B. Fault in the section A to B. Okay. For fault in the section B to C, what will be the time of operation of relay RA? 2.97 into x1. And minimum operating time given in the problem is 0.2. So the next constraint would actually have been 2.97 x1 greater than equal to 0.2. But that is redundant. That is redundant. If I am saying that 2.63 x1 should be greater than or equal to 0.2, definitely 2.97 x1 will be greater than or equal to 0.2 because 2.97 is greater than 2.63. So no meaning in saying, no meaning in adding and constraint 2.97 x1 should be greater than or equal to 0.2. उसको छोड़ देंगे. Now for fault in the section BC, time of operation of relay B is 2 times x2 and that also has to be greater than or equal to 0.2. So 2 times x2 should be greater than or equal to 0.2. So we have taken into account everything. We know that time multiplier settings of relays cannot have negative value. That is why we should write x1 x2 greater than equal to 0. यहाँ लिखने का भूल गया हूं मैं, but it has to be there. x1 x2 greater than equal to 0. Now have a look at the problem. Forget about electrical engineering. Forget about overcurrent relays. Forget about overcurrent relay coordination. Forget about fault current and everything. Forget about all these things. Just look at the problem. Just look at the problem. You will say that it is a linear programming problem. Constrained linear programming problem. And how we can solve this? We can solve it very easily using lean-prog. This is how lean-prog can be applied to electrical engineering problem. Only thing is that I will have to take care, which I have said. Objective function should be of minimization type. Yes, it is already there. No problem. Then the constraints, inequality constraints should be of less than equal to type. So I will have to write the constraint number 1 as minus 2.97 x1 plus 2x2 less than equal to minus 0.57. Likewise, I will say minus 2.63 x1 less than equal to 0.2 minus 2x2 less than equal to 0.2. Constraints converted to less than equal to type. After this, I will simply apply lean-prog function. I'll simply apply lean-prog function, and with that lean-prog function, I get the solution as time multiplier setting of relay 1 is 0.2592 and that of relay 2 comes out to be 0.1. Remember that this type of quantity 0.2592, when I am saying that 0.2592 is the time multiplier setting of relay 1, I am considering that the relay is numerical relay. The old relays, electromechanical relays, they cannot be set to 0.2592. 0.2 रहेगा, 0.3 रहेगा, 0.4 रहेगा, something like that. Or maybe if you have more accurate relays, it can be 0.25, 0.26, but it cannot go to 0.2592. Time multiplier setting of 0.2592 can be set only in numerical relays, cannot be set in other type of electromechanical relays. So this is how I can apply lean-prog function. Now let's see. Actually, I have got one more problem, one more example. We'll go through it very fast. Single end fed system with parallel feeders. Here I have taken 4 relays, 2 feeders, parallel feeder system. Consider fault at the midpoint of feeder PQ, that is point A, and at the midpoint of 3, 4, that is point B. The data is given And exactly in the same way as I did for previous problem, the problem is formulated. Now, relay 1 looks for fault at point A as well as point B. Relay 4 also looks for fault at point B as well as point A, but relay 2 looks for fault at point A only towards left side. Relay 3 looks for fault on this side. So this is the objective function. After calculating the AI constants, the problem can be formulated as this. This is objective function. These are the constraints. And then, see, here you can see that how one becomes redundant. Here I have taken care of minimum operating time constant and the TMS constant. Because of TMS constraint, in place of this, I will be using x2 greater than equal to 0.0174. x2 greater than equal to, see, this 5.749 x2 greater than equal to 0.1 gives me that x2 should be greater than or equal to 0.0174. But there is limitation on the lower limit of TMS. TMS lower limit is 0.025. So x2 has to be greater than or equal to 0.025. So I'll replace this constraint by x2 greater than or equal to 0.025. These are the coordination constraint. Now there are two coordination constraint. In the previous problem there was only one. Now we have two. And then the non-negativity constraint x1, x2, x3, x4, they all should be greater than equal to 0. You will get a linear problem. You solve it using lean-prog. The values of time multiplier setting for relay 1, 2, 3, 4 are like this. So this is how we can solve overcurrent relay coordination problem using lean-prog. If you are considering relay electromechanical relay, you will have to make special arrangement such that the relay should acquire the time multiplier setting should acquire the value in fixed state. It cannot be any fractional value. It can be fractional value in fixed state for electromechanical relay. Now let's see, थोड़ा सा फास्ट ले लेंगे. Transmission line fault location. I can model the transmission line by lumped series representation or pi section representation. Instantaneous values of current and voltage at the relay location are related through differential equation. The problem of fault location. See, this problem, locating the transmission line fault, this is basically not an optimization problem. अभी थोड़ा सा fast लेता हूँ because of the time constraint. We have less time. So, transmission line fault location. This problem is basically not a optimization problem, but I have formulated the problem such that it becomes a optimization problem. Let's see. Simple. I have taken a simple system. Simple system, lumped series representation R and L. At present, I am neglecting C. In case of pi representation, you will have to take half of C on left side, half of C on right side. There is a fault. The voltage can be represented as RIK plus L DIK by dt. RI plus L di by dt. Derivative can be obtained at any instant of time. Derivative of current can be obtained using numerical method. This is numerical method of finding the derivative. Value of current at the next instant minus value of current at the previous instant divided by 2 times the time interval between the instants. So this way you can find out the derivative. And then you can find out error. Calculated, see, you do not know R and L. What is your aim? You want to locate the fault. Location of fault means what? You want to locate that at how much distance from the relay the fault is. Fault is at how much distance from the relay location. How that distance can be calculated? That distance can be calculated by knowing the resistance and inductance between the relay location and fault. So basically you have to find R and L, resistance and inductance. These two things you have to find out. So what we are doing, we will assume some value of resistance and inductance. And with that assumed value, we will calculate the voltage. Vk is equal to Rik plus Ldik by dt. The sample of currents we are taking the current samples and voltage samples. So current samples are available. As the current samples are available, I can take Ik. I can also take dik by dt using the formula. So what I am doing, I am calculating the voltage. On the other hand, actually the voltage at that particular instant is also available with me. As I said that I have voltage sample and current sample both. So voltage sample to available hai. I am using the voltage sample which is available Vi, and I am also calculating the voltage by assumed value of R and L. And the difference between these two voltages is called error. This I will do for different time instants. And then what I will do, I will try to minimize the sum of square of errors. Least square error, sum of square of errors, I will try to minimize. When I am minimizing the error means what? I am trying to make Vi is equal to Vi calculated, or actually I should say reverse. I am trying to make Vi calculated almost equal to Vi. Vi is actual value, correct value of voltage. I am trying to make Vi calculated very much equal to Vi. How can I make that? If I get the correct value of R and L. This problem can be easily solved using genetic algorithm or some nature inspired algorithm. What I am doing then, I am trying to reduce, minimizing the sum of square of errors. So this becomes my objective function, and I have converted the problem into optimization problem. So my aim is to find R and L so as to minimize sum of square of errors. And there is no constraint. So the category of problem is unconstrained nonlinear programming problem, which can be solved using the function f mean unc. Let's see the results. Just for comparison of the result, I have taken fixed value of resistance and inductance. Using PSCAD, I have got the current sample and voltage samples after creating the fault. And then I have applied the algorithm, different algorithms. I have calculated the value of resistance and inductance, and I have found out percentage error. The same problem has been solved using 4 different methods: simultaneous differential equation method, nonlinear programming method, MVS LSQ, multivariable series least squares technique. Those who have studied or those who are teaching digital protection, they must be knowing this method. Multivariable series least squares method, MVS LSQ. And the problem is also solved using genetic algorithm. And the results obtained using different methods is given, and they are compared in graphical manner here. And it is shown that the genetic algorithm is giving minimum error in the value of resistance and inductance. That is, it is giving the better fault location. Same thing can be done with the help of with taking the pi representation of line. In the earlier example, I had taken the lumped series representation. Now I am taking pi representation. The equations are slightly different. Now instead of Ri plus Ldi by dt, V will now be written as R into I minus IC. Total capacitance is 2 times C. Half of that is C, is taken on left side. Half of that is other C, is taken on right hand side. So this is the formula for voltage. which can be expanded and can be written as Ri plus Ldi by dt minus Rc dv by dt minus Lc d square v by dt square. Okay, I'm not going to take details and explain this expression. Basically, the thing is that I have got a formula to calculate the voltage. I will assume the value of R, L and C, and with the assumed value of R, L and C, with the help of current samples and assumed value of R, L and C, I will calculate the voltage. And at the same time, I also have actual voltage. So difference between actual voltage and calculated voltage is the error. If the error is 0 or very small, it indicates that calculated value of voltage is very much near to actual value of voltage. What does this mean? That I have got the correct value of resistance, inductance and capacitance between the relay location and fault point. And that is what was required. So again, the problem is formulated as a non-linear, unconstrained optimization problem. What are the research opportunities in this? Is this the end? No topic is finished. You pick up any topic and that topic has definitely got some or the other research opportunity. What you can do here, you can think of improving in transmission line fault location using other optimization techniques. I have used 4. You can use other 4. What other thing can be done is, instead of lumped series parameters, distributed parameter model can be taken. That will be more accurate, that will be more better. And one important thing is that in my model, I have considered fault impedance to be equal to 0. One can consider the fault impedance to be non-zero and proceed further, and it can lead to a research work, definitely. Let's take another problem, overcurrent relay coordination 2. So we have seen that, of course, I am taking only one example because I cannot take more. हर एक type का एक ही ले रहा हूँ, time restriction है. But I have shown that how electrical engineering problem, or in what case electrical engineering problem fits into lean prog. In what case electrical engineering problem is fits for F mean UNC. Now I am proceeding for the third, F mean con, overcurrent relay coordination 2. In this case, the theory I have already covered. The constraints are of 5 categories. Coordination criteria is also already there. Relay operating time constraint, time multiplier setting constraint. Now, if I am saying that plug setting is not fixed, I am trying to find out, say, what I am doing now, what I did earlier. In the first problem, I considered that the plug setting multipliers of the overcurrent relays are known and fixed. Now I am considering that the plug setting multipliers are also variable. I can find out the optimum value of not only time multiplier setting, but I am also trying to find out the optimum values of plug setting. And in that case, the TMS constraint and the operating time constraint cannot be combined together. So they will have to be kept separate. So they are separate. Then the constraints on plug setting, as now I am saying that plug setting also is to be found out. So there is limitation on plug setting, lower limit, upper limit, and the relay characteristic constraint. So now instead of 3, we have 5 set of constraints. Let's take a system. Of course, lambda and gamma depends upon the type of our current relay. Same system. Let's see the same system. Same data, same parameters, everything same. Only thing is that now I am not saying that the plug settings are 1. Plug setting is to be found out. And थोड़ा सा CT ratio में change कर दिया है. It is 600:1 for relay RA and 200:1 for relay RB. See, when we are talking about finding the plug settings also, we have to deal with maximum load current also. It is not only the fault current which will help us now. What else is required is the maximum load current also. So here I have taken load currents. Along with fault currents, I have taken the load currents also. The minimum operating time of relay is again taken as 0.2 second, and the coordination time interval is again taken as 0.57 seconds. So with this data, when you proceed further, when you apply your domain knowledge, see, I am saying since yesterday, I am repeating this sentence many times that what is important is your domain knowledge. You must be sound in your domain knowledge so that you will be able to formulate your problem properly and correctly. Once it is formulated properly and correctly, you just have to apply the tool. Simple. As we have seen in case of overcurrent relay coordination 1. I have acquired some knowledge. I don't say that I have got entire knowledge of overcurrent relays and all that, but I have acquired some knowledge. I have gone through the literature and I could formulate the problem. So I can get the solution very easily. No, absolutely no problem. Just apply lean prog and get the solution. Likewise here, now you should be able to formulate the problem properly. Let's see the formulation of the problem. Here, as the plug setting is not fixed, for two relays, there will be 4 variables. Time multiplier setting of relay A and relay B, 2 variables, x1, x2, and plug setting of relay A and relay B, because I have to find out the optimum value of plug setting also. So, plug setting of relay A and relay B, that is x3 and x4. 4 variables. For 2 relays, 4 variables. Minimize, the objective function becomes minimize 0.14 x1 upon 6.667 divided by x3 raised to power 0.03 minus 1. So this way you have to find out the different terms. You can see that because the plug settings are not fixed, the problem is non-linear. Each term of the objective function is now a non-linear term. Same thing will be there with the constants also. These are the constants: minimum operating time constant. Minimum operating time constant. Time of operation of relay RA. For fault beyond bus A should be greater than or equal to 0.2. Similarly, if there is and of course relay RB will not look at the fault in the section A to B. But if there is a fault in the section B to C, it will be sensed by and looked by both relay RA and RB. So for section A to B, there will be 1 constant. Section B to C, there will be 2 constants. This way we have minimum operating time constant 3 in number. And as it is a simple system consisting of only 2 relay, there is only single primary backup relationship. There is only one primary backup relationship. So there will be only one coordination constraint. This is coordination constraint. You will find that the terms are non-linear. And you can just think the complexity of problem. Even if the system is very simple, system consists of 2 relays only one primary backup pair, the problem looks very complicated because of non-linearity in nature. So, of course, x1, x2, x3, x4, neither the time multiplier setting nor the plug setting can be negative. So, they all should be greater than or equal to 0. What is this problem type? The type of the problem is non-linear constraint optimization problem. So, category, constraint, non-linear optimization problem, non-linear programming problem. Which function I can use here to solve this problem? F mean con. Or I can use even GA. I can use GA. जेनेटिक एल्गोरिथम वो टूल भी है, पार्टिकल स्वॉर्म ऑप्टिमाइजेशन का भी टूल है, सिमुलेटेड अनलिंग का भी टूल है. आई कैन यूज एनी ऑफ दीज टूल्स टू सॉल्व दिस कैटेगरी ऑफ प्रॉब्लम. F mean con and GA we have already seen, so that can be used over here. And using F mean con, see, once I have formulated the problem, I can very easily deal with the problem. Absolutely no issue. I can write the objective function. I can write the constraint, what care I will take. I'll see whether the objective is minimized or not. Yes, it is minimization type. I will proceed for constraint. I will convert all the constraints into less than equal to type. And as the constraints are non-linear in nature, I will transfer everything onto left-hand side. And then I will say that I am ready with the problem. And I will then apply F mean con. मुझे बेसिकली मुझे प्रॉब्लम सॉल्व नहीं करना है. आई डू नॉट हैव टू सॉल्व द प्रॉब्लम. आई जस्ट हैव टू रीफ्रेम द प्रॉब्लम, प्रिपेयर द प्रॉब्लम सो दैट आई कैन fit it into F mean con, and F mean con will solve the problem and give me the result. Likewise, I can, once I formulate the problem properly, I can even use GA, that is genetic algorithm. The optimum values which I have obtained are like this. Time multiplier setting 0.1353 and 0.1 respectively, and plus setting 1.4885 and 0.5117. Looking at the values, again it is clear that I have assumed the relays to be IDMT relays, and that too numerical relays. An electromechanical relay cannot have plug setting is equal to 0.5117. Possible nahi hai. Electromechanical relay cannot have time multiplier setting is equal to 0.1353. Not possible. But then one can solve. I have solved a problem in which I have considered some relays to be of electromechanical type and some relays combination of electromechanical and numerical relay. And I have also taken combination of IDMT relays, very inverse relay and extremely inverse relay. Then only it becomes a problem of research, otherwise not. What are the research opportunities for which one can think? Take a considerably large system. This is a system, 24 relays, 9 feeders and 24 relays. You can just think how many primary backup combinations will be there. But still there is one thing which has made the system simple. Even though it is large, it is simple because it is single end fed system. The system which I have considered, which I am showing over here, is having generation connected to bus number B1 only here. If you consider that you have generation here as well as here, let's say at bus number 9, the complexity increases. So consider a considerably large system. The system which I have shown have 9 buses, 24 relays. As there are 24 relays, there will be 48 variables in the problem. And you cannot solve this problem manually. You have to go for computerization, computer program. 24 time multiplier setting, 24 plug setting. There are 27 primary backup combination. If you write the problem properly, if you think that about the primary backup relationship, there are 27 coordination constraints, 24 operating time constraint, 24 TMS constraints, and 24 plug setting constraints in this particular system. So if you want to go for research, consider take a considerably large system. The other thing that you can do is consider a multi-end fed system. As I have said that I have shown you a diagram which is a large system, complex system, but still it is simple because it is having only, it is a single end fed system. You can consider multi-end fed system. Consider the presence of fax devices. Like this, you can go for different things and you can proceed for research. Now, I have few more examples, but we are leading short of time. So I will now, instead of going for problems of optimization, now I will go for an appeal to all. Let's have a look. I'll now conclude my session within 5 to 6 minutes with an appeal, which is also in which optimization is also included. I am trying to minimize my electricity bill. Minimizing means optimization. To minimize electricity bill, what we can do, we can take many number of things, out of which today I would like to concentrate on only one thing, and I will appeal all of you that if you have not done that, then you should go for that. And what is that? This is my energy bill for the month of April 21. What appeal I want to put is save tree, save earth, and go green. This will also minimize your electricity bill. See, when you receive an electricity bill, those who are the participants from Maharashtra, outside Maharashtra participant, I don't know, because what type of electricity bill they get, I don't know. But at least for the participants who are from Maharashtra, they used to get this type of electricity bill every month. At the bottom, you will see Mahatvache, that is important. Let's read this. I will show this particular sentence separately. महत्वाचे, छापील बिलाऐवजी ई बिलासाठी नोंदणी करा व प्रत्येक बिलामागे 10 रुपयांचा गो ग्रीन डिस्काउंट मिळवा. मिनिमाइजिंग द इलेक्ट्रिसिटी बिल. Okay, so if you have not gone for go green, what you have to do, those who cannot understand Marathi, I can just say in brief that what appeal Maharashtra State Electricity Distribution Company is making is you go for e-bill instead of hard copy of electricity bill. Try to avoid hard copy. If 1 lakh consumers from Amravati avoid hard copy, then 1 lakh pages of paper per month will be saved. This is regarding Amravati only. So you can think how many trees will be saved. And at the same time, so we are helping the society, we are helping the nature, and at the same time, we are minimizing our electricity bill. 10 rupees per month discount. What you have to do? You have to go to this particular site, which is mentioned over here on your electricity bill. When you go to this particular site, see, it is mentioned over here. What it needs is only 2 things. One is your consumer number and one is your go green number. On every, see, your consumer number is fixed. The same consumer number will appear on all electricity bills which belongs to you and to the same meter. But the go green number will go on changing every month. So whenever you are trying to go, you see latest month go green number. Here is go green number. At the top left side, bill number within bracket GGN. GGN is go green number. This is go green number. When you go to this particular site, it will ask you only two things which are mandatory and one which is optional. When you go to that site, it will look like this, which asks you for consumer number. So enter the consumer number. From where you are getting consumer number? It is available here, consumer number. This is consumer number and this is go green number. So enter the consumer number and just click the button search. It will search and display everything. Your consumer number is this, name is Prashant Prabhakar Bedekar, billing unit is 4295, Amravati urban area, and all that, Amravati urban division, Amravati circle, zone, Amravati zone. 2 more things are to be entered, out of which one is mandatory, that is go green number, which is also available on the electricity bill. So just type that go green number and then give your email ID. This is not mandatory, this is optional, but you can give the email ID also. So give your email ID. After that, these are some of the conditions. You have to agree to the condition just by checking in this particular block. Check this block, I agree, and it will display this type of screen. You just have to click on the submit button. So submit this and you will get this type of screen. Go green with e-bill. Your Go Green application is submitted. And the important is that now you will not receive hard copy of energy bill. So every month I am saving 1 page of paper, and at the same time I have minimized my electricity bill by 10 rupees per month. Some of the people say that if I do not receive hard copy of the bill, there will be a problem, because wherever I have to go, I have to give address proof, I have to give electricity bill. So there is absolutely no problem. Nowadays, the e-copy is also available. You can take printout of the e-copy. This is printout of my April 2022 bill. I opted in April 21 for Go Green. If some organization says that no, this is computer printout, I will not accept. Bring original copy. You can just show them that I have opted for Go Green, so I do not receive hard copy. This is the copy received from internet, from the official website. If you want, you can check. Opted for Go Green. This is sufficient to say that I do not receive the hard copy, and this is the copy which is downloaded from official website mahadiscom.in. Every bill will have Go Green discount of rupees 10. You can see on every bill you will find Itar Akar, other charges, minus 10. This minus 10 is because I am trying to save the paper. So see how much discount is given. I am saving only 1 page per month. And for that 1 page, the discount given is 10 rupees. So of course, this is related to optimization. I am minimizing my electricity bill, but it is an appeal for the social cause. Go Green. Thank you very much. I conclude my session over here. I have given my contact details, my address, email ID, mobile number. Thank you very much for having patience for such a long time. If you have any question, you can ask. Thank you very much. Or otherwise, you can send your questions by email also. Thank you.
Am I audible, sir?
Yes.
Good afternoon, sir. And session was very informative.
Thank you.
So thank you for the session. And my question is, uh, actually, in some paper, some research paper, there are some algorithm. So my question is that how to understand that algorithm and how to convert that algorithm into the MATLAB code.
So actually, to understand the algorithm, you will have see the papers do not give algorithm. Say, for example, in one of my paper, I have used genetic algorithm for overcurrent relay coordination. But in that paper, I have simply given how genetic algorithm can be used for overcurrent relay coordination. That paper doesn't contain genetic algorithm. What you will have to do, if you want to understand genetic algorithm, you will have to search the basic papers or the literature on genetic algorithm. Same is the case with any other thing. I have come across a paper wherein Firefly algorithm has been used. So then I downloaded few papers on Firefly algorithm. Of course, I could not find time to go through that. But then basic thing is that how to understand the algorithm is you will have to go for the basic papers of that particular algorithm. Those algorithms can be available in the research papers or may be available in the books. You can go through that, and for converting it into MATLAB program, what I suggest is you should apply the algorithm step by step manually by taking a small problem. Take a very small problem. What I did afterwards in this HTTP, you will be studying, or you will be coming across Jaya algorithm, and you are very fortunate. You are very fortunate that the person who has given that algorithm will be explaining that particular algorithm, Jaya algorithm. Dr. Rao from SBNIT Surat. I think he is one of the resource person. So when I came across that algorithm in one of the paper, I searched for the basic paper of Jaya algorithm, and then I solved one or two problems, small problems manually. When you solve the small problem, see, you cannot solve big problems manually. They become very complex and we make mistakes. So take very small problem. Take very small problem. Try to solve the problem manually. What happens that you get very minor things, very small things which are related to that particular, say, optimization technique. And then once you solve two or three small problems, you come to know that what is to be done, what step is to be taken after a particular step, where the looping is to be done, what should be the criteria for stopping the algorithm. All these things become clear when you solve small problems using any algorithm. So I did the same thing for genetic algorithm. I did the same thing for particle swarm optimization, Jaya algorithm. So you have to read the basic papers or books wherein you will find the steps of that particular optimization technique or new algorithm. And then again, I say that to have a better feeling and going for programming, it will become easy only if you solve your own manually 2 3 small problems. Then only you can go for programming. Okay.
Okay, sir. Thank you very much. Thank you, sir.
Okay. 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 If there is any other query, I will try to answer. Or as I said, otherwise, other query or problems, you can ask through via email.
Screen. Yes, participants, do you have any queries? Hello? Yes, participants, if you are having any queries, you can put those queries in chat box. Otherwise, you can also mail to our respected resource person. Am I
Am I
audible to
audible to
everyone?
everyone?
Yes, madam, you are audible. You are audible.
Hello?
Hello.
Madam, you are audible. You are audible.
Hello?
Hello.
Am
Am
I
I
audible?
audible?
Yes, madam, you are audible. It seems that the participants do not have any questions to be asked at present. You are audible, madam. No problem.
Yes, sir. Yes,
Yes,
participants.
participants,
Do you
do
have
you have
any
any
query
query
or
or
any
any
questions
questions
you would
you would
like to
like to
ask,
ask,
sir?
sir?
Yes,
Yes,
sir.
sir.
So, shall I conclude the session then?
I think some voice problem is there. Thank you very much, sir, for such a wonderful session. You have really taught us about how the optimization techniques can be applied for electrical engineering problem by giving the example of relays system. Also, thanks for your
Go Green appeal, definitely we follow that link to have the optimized electricity bill. Thank you,
Yes,
sir.
thank you, madam.
Thank you very much for such a wonderful session. With this, with the permission of resource person, I will conclude today's session. And all participants,
I have one
tomorrow
question.
we will be having another
Yes, yes,
session
yes.
right
Madam,
at
I
sharp
have
9 a.m.
madam,
Please
madam,
join for
Telangan,
tomorrow's session.
tell
Thank
madam.
you. Thank you to all.
hello. I have
Telang,
one question.
yes, yes, ma'am. Yes, sir, you can ask.
Doctor,
Mr. Ramesh, you can ask, please.
yeah, Dr. Prashant, your presentation is lovely. We do a lot of relay coordination and we work on ETAP and many various software.
Yes, sir.
And
Thank you.
yeah, fine. And your presentation, time multiplier, settings, all these things done very well. I have one question.
Yes, sir.
Uh, I'm working on IBR Reach Grid.
Pardon?
I am working on IBR Reach Grid. That means inverter-based resources connected to the grid.
Okay.
And I'm IEEE committee member working with USA
Okay.
with a lot of people, and I'm a secretary for that. And luckily, I'm in India, and I could attend your lecture.
Okay. Thank you, sir.
I want this thing. Nowadays, you see solar, renewable energy, wind energy, battery storage getting connected to the grid.
Correct.
So my question is, we may have to, are these numerical relays algorithm will work to protect the grid? Because the fault at converter is quite different than the normal grid without IBR.
Correct.
So we have to rewrite the algorithms for this IBR rich grid, which we cannot stop penetration of renewable energy. Have you worked on that?
No, no. I have not worked on this particular topic. But then, if at all it is required to take combination of relays, that can be done. I have worked with combination of relays. I have not worked with the renewable energy penetration and all that. But in some systems, I have taken combination of different characteristics of relay. I mean, IDMT, very inverse, fixed time, and all that. And I have also taken combination of electromechanical. Few relays I have considered electromechanical, and few relays I have considered numerical. So that I
Yeah,
have worked. But I have not worked on the penetration of renewable sources. That I have
because
not.
because I'm trying to direct some research there, and we don't have right now that skill and tools to work on that and how the impact will be. There are a couple of professors in American university.
Okay, okay.
You may be knowing Dr. Arun Phadke also, right?
Yeah. He's great fellow in the
Yeah,
field of
yeah.
production.
I
Yeah.
had many times couple of meetings on PMU and synchronous phasor, phasor synchronous method and all. I meet all the authors in the world.
Okay,
In the
okay.
world, traveling.
Yeah.
I do a lot of
Yeah,
traveling,
fine.
but good. Arun Phadke is good. Along with him, there was Dr. Thorpe.
Yes.
He's no more in Virginia Tech.
Oh.
And yeah, then 2019, IEEE president came to my Dubai house and all. We meet and we deliver lecture. But
Okay.
then I have put this and I have asked some university to know the result. Where are the malfunction of these relay? What you are done is a pure grid without IBR.
Yeah.
So these relays are functioning well. We have everything. We have 6 1 everything. But
Yes.
now the things are, the grid is no more virgin.
Correct.
So my really grit feeling and gut feeling is that we may have to rewrite the algorithms
Yeah, correct.
for IBR Reach. So
Yeah.
we will take it this session after some time in the evening because I respect everybody's time. I
Yeah.
appreciate the well thing you are given, lot of practical approach you are given because people are not aware of it, and that's good. Thanks.
Thank you, sir. Thank you very
Thank
much.
you. Appreciate.
Thank you, sir. So with this, we conclude today's session. Thank you, Professor Dr. Bedekar, sir. Thank you, Ramesh Suryavamshi, sir, for your wonderful information and the work related with the renewable sources. Thank you, sir. So with this, we conclude today's session.
Thank you, madam. Thank you. I am thankful to all the organizers, all the say authorities and faculty members of P.R. Pote Patil College of Engineering and Management, as well as St. Vincent Pallotti College of Engineering. Special thanks to the organizers. Thanks to Telang madam, Shahakar madam, Gadge sir, Dote sir, those who have given me an opportunity to interact with different people in online mode on the topic of my interest, that is optimization. Thank you, madam.
Thank you so much, sir. Thank you so much.
Thank you, sir. Thank you.
So I am leaving the meeting now. Madam, is it okay?
Yes, sir. Yes, sir. Sure.
Yes, sir.
Okay.
Yes.
Thank you, madam. Thank you.
Thank you.
Thank you, sir. Thank you.